These aircraft, operating with the Air National Guard in April 1971, were among the last of their type in US service. 8 months later, the last F-84s were decommissioned and delivered to the scrapyard. Most of the Thunderjets had long gone by then. Only this variant, the reconnaissance plane known as the RF-84 Thunder Flash, had lingered on in any numbers, due to their operational usefulness as specialists. By 1971, the planes were showing their age. Many had been grounded due to structural fatigue, and those that still flew required constant monitoring and a heavy maintenance schedule. The last of the RF versions had rolled from the factory in 1957, and they had led very busy operational careers. The Thunder Flash photographic planes were the most successful development of the F-84 family and embodied all the advances that had been made during the design's career, which can be traced back to October 1944. At that point, the design team at Republic had abandoned the idea of putting a jet engine into the redoubtable P-47 Thunderbolt and had set to work on a clean sheet of paper to develop a new aircraft. The United States had found itself confronted by the arrival of new German and British jet aircraft. In the next few years, the US Army sponsored a feverish effort to catch up. The Bell and Lockheed corporations developed the first two US jet aircraft, and the Lockheed P-80 was ordered into production. Meanwhile, the Republic team had devised a sleek and extremely clean design built around the new axial flow engine developed by General Electric. The achievement was impressive, and the Army ordered commencement of work on 3 prototype planes as the XP-84. The first plane was completed in December 1945 and then was transported to the Muroc Testing Center for Army evaluation. There, on the 28th of February 1946, the new plane took to the air for the first time, becoming the first post-war American fighter. The design was fairly conventional, with straight wings employing the so-called laminar flow profile. The plane was of all-metal construction, with the wings mounted low on the fuselage. Under the teardrop canopy, the cockpit was pressurized and contained an ejector seat. Though not technologically adventurous, it was an aircraft with classic lines, incorporating most of the proven ideas of the day. Models were rapidly evolved in relatively small numbers until the E model appeared in 1949. While over 840 of the E model were built, design work continued to refine the plane, and many improvements were retrofitted to the early models. For example, this E model has been refinished with many of the improvements developed for later variants. From the start, there were problems with the new plane. In the main, these were the same problems evident in other early jets. They reflected lack of knowledge about the needs and potential of the new power plants. In its later career, the plane evolved gradually until it looked radically different from the trim 1946 prototype. The most obvious flaw in the design was the straight wing, and go-ahead was given to develop a swept-wing version. The other major flaw was outside the designer's control. The Thunderjet was badly underpowered. All the early jets shared the problem of low power and required excessive runway to take off. Under full load, it was safer to employ rocket-assisted takeoff rather than hope the plane would be airborne before it ran out of runway. All too often, planes did run out of takeoff room. hundreds of pilots around the world wrote off their Thunderjets in that way. The assisted takeoff gear would still be needed on the later swept-wing models, as the increased power of their engines was absorbed by their increased weight. But development was slow, and as an interim measure, an improved straight-wing version was put into production. This, the G model, was built in greater numbers than any other version, 3,025 being constructed. The plane had originally been designed as an interceptor, relying on 6 machine guns, 4 in the nose and 2 in the wings. The Thunderjet had superseded the Lockheed P-80, which was designed 2 years earlier. However, with the speed limitations imposed by its wing and underpowered engine, the F-84 was soon itself supplanted as interceptor by North American's F-86 Sabre. With this rapid succession of models, the Army found itself with a variety of planes to allocate specific tasks. In the carve-up of roles among the three, the Thunderjet evolved as a fighter-bomber, and by the time of the G model, had been given the ability to carry out nuclear attacks. Its conventional stores carrying was also developed. It was in tactical support and air-to-ground strike operations the Thunderjet was to gain its fine combat reputation. Its low-mounted wing was an asset in this transformation, allowing easy loading of arms with minimal equipment. With the ability to carry up to 4,000 pounds of bombs, the Thunderjet packed a powerful attack. With the takeoff assistance of rockets, it was able to operate from short frontline strips in fairly rough conditions, and rugged construction gave it the ability to absorb considerable small arms fire and stay in the air. Adding further to its power in ground attack were the 6 machine guns, which carried 300 rounds each. There was provision to sling up to 32 5-inch rockets under its wings and fuselage, reflecting World War experience attacking tanks. As a further variation in strike power, the plane could deliver a deadly load of napalm. The plank wing planes were limited in speed to Mach 0.82. This effectively killed the plane for air-to-air combat. Above that speed, it reacted violently enough to cause structural failure. Another major impediment to use as a fighter was that maneuverability was very limited. However, the lack of turning ability was an asset in ground attack, as the plane tended to fly rock solidly and was a stable platform. And the limitation on speed was no disadvantage in ground attack. Despite their persistently dubious takeoff habits, they were to excel in the tactical role. The original production version, the B, had been a very basic aircraft, little advanced on 1945 piston-engine fighters. However, as models and submodels were developed, the plane's sophistication increased. By the G version, the planes had gained radar-assisted sighting, an autopilot, and revised electrical, fuel, and hydraulic systems, along with a host of other improvements. The early jet engines were very fuel-hungry, and the Thunderjet had limited internal storage. The addition of wingtip tanks boosted capacity, but the range of the early planes was limited to 1,200 miles or so. By the time the G model was introduced, its range had been increased to 2,000 miles, but a very important addition was made to that model. Because it was employed by the Strategic Air Command as an escort fighter, it received in-flight refueling provision. Curiously, the receiver was installed in the left wing, disrupting airflow over a considerable proportion of the wing surface. The G model had only been developed because of delays in getting the swept-wing version sorted out. However, by 1952, the plane was ready for its first flight. The new model had originally been given a new number as the F-96, but this had later been changed back, and the swept-wing plane became the F-84F with the company name Thunderstreak. Once again, the performance of the aircraft in its intended fighter role was disappointing. The increased power of the engine and potency of the shape was swallowed up by the increased weight of the plane, and it shared the earlier model's sluggishness, especially in the dangerously unwilling takeoff. In comparison to the G model's 622 miles per hour, the F model could attain 695. However, in climb and ceiling, the new model was worse than the straight-wing planes. The F model followed its earlier brothers into use as a tactical fighter bomber. The swept-wing model had been delayed repeatedly. The overriding restriction on development was caused by budgetary constraints. Congress was keeping the purse strings tightly closed, and the Air Force simply had no money to allocate to the project. The prototype flew on June 3rd, 1950. It was immediately obvious that a more powerful engine was needed. But there, the project stalled, and it was to take a massive stimulus to reinvigorate the development program. Only 22 days after the first flight of the swept-wing model, word of an invasion of South Korea by communist forces from the north reached the United States. The floodgates were opened in a flow of defense dollars that has continued with barely a hiccup ever since.
Although many countries promptly disbanded their wartime armies, other countries continued to maintain forces so large that they posed a constant threat of aggression. And this year, the invasion of Korea has shown that there are some who will resort to outright war, contrary to the principles of the Charter, if it suits their end.
When war in Korea broke out, the United States Air Force was a mere shadow of the mighty machine of victory that had existed 5 years earlier. The South Koreans simply did not have an Air Force. They had 16 aircraft, all trainers or liaison aircraft, with not a gun or bomb rack between them. Airfields were few and rudimentary. The workload therefore fell initially to piston-engined aircraft to operate from Korea. American jets were forced to operate from Japan and arrived at the battlefront with limited loitering time available. The force the US could deploy in the air was barely adequate for the task, and if the North Koreans had had a decent air force, the whole of the peninsula may have been quickly overrun. In fact, the North had 62 light attack planes and 70 outdated fighters. This force was very promptly destroyed, and the Americans were able to first slow and then stop the northern advance. Heavy bombers were employed in a combination of interdiction and strategic raids, which helped to paralyze the northern effort. In combination with Navy aircraft and the few types the Air Force could deploy usefully from the limited Korean airstrips, the US gained air supremacy and was to maintain it for most of the following conflict. Given the initial weakness of the ground forces, it's clear that victories in Korea in late 1950 were almost solely due to the American aircraft. F-84s were not initially deployed to Korea. Mustangs and P-80s were quite capable of doing the job. But on the 9th of November 1950, the situation changed radically. The North Koreans started to deploy jets. Within days, the United States was forced to deploy more modern aircraft to the conflict. The Thunderjets available were straight-wing D and E models, and they were never the equal of the MiGs. However, the F-84s, though not capable of downing the speedy Russian designs, were just fast and maneuverable enough to usually avoid trouble. Less than a month after the appearance of the MiG-15s on December the 6th, the first F-84 combat missions were flown. The planes had been shipped to Japan, where the damage from salt corrosion was remedied, and along with F-86 Sabres, were committed to the battle. Outclassed as a fighter by the two swept-wing jets, the F-84s settled into a life of tactical air-to-ground missions. Most of the time, they required Sabres as mission escort if there was a likelihood of running up against the MiGs. The Russian planes were simply too fast for the Thunderjets to cope with. In their tactical role, the F-84s would prove invaluable. By the end of the war, they'd flown 86,408 sorties. In that time, they had dropped 5,560 tons of napalm and 50,427 tons of bombs. They had fired 22,154 rockets and a huge number of rounds from their machine guns. The infantry were, in a mixture of awe and gratitude, to dub them the champ of the fighter bombers. Nine MiGs were officially credited as shot down by Thunderjets, and another 96 were listed as probably shot down or certainly damaged. Against this, the MiGs shot down 18 Thunderjets and damaged many more. Anti-aircraft fire was to claim a greater tally of the F-84s. 135 were shot down by ground forces. Though some missions were flown from Japan, relying on in-flight refueling, the Thunderjets were tough enough and had sufficient ground clearance to be operated from the rough and ready facilities in Korea. This often required that they use assisted takeoffs, with the rocket packs being jettisoned for retrieval and reuse. This was less than ideal, as in squadron formation the rocket smoke was so dense that only the leaders could see, and the following planes had to take off on instruments. The routines of briefing, preparation, takeoff and attack became familiar. The F-84s took on a great load, not only in ground support at the front line, but in interdicting supplies, attacking reinforcements and destroying bridges, railways and power stations. In the last of these tasks, they actually operated as a strategic force, a reflection of the way in which they'd established themselves as trustworthy, rugged and deadly. They had proved themselves as a primary weapon in the Air Force's arsenal. The greatest virtues possessed by the Thunderjets were all underlined in Korea. They were, especially in comparison to other early jets, easy to maintain. They were also stable and effective attack platforms, capable of withstanding considerable damage. Their performance was simply workmanlike, especially if compared to their Republic relatives, the P-47 of the Second World War and the great F-105s, which played such an important role in Vietnam. However, despite their limitations, they were the most effective jet attack plane in the Air Force during the Korean conflict. The Thunderjet starts to emerge from the cloak of its failings and be revealed as a very important and successful aircraft. Its greatness has to be seen in the context of the era. Many early jets were far less effective and successful than the F-84. Their contribution in Korea might best be described as worthy. But the reason the tedious, difficult, repetitive and dangerous tasks of the conflict fell to the Thunderjets is simple. They were capable when all around them other types failed the test of combat. The Thunderjets had their vices and their limitations, and they earned some of the most unflattering nicknames ever bestowed by US pilots on their aircraft. These nicknames included Groundhog, in reference to their unwilling and sluggish takeoff. During Korea, the crews amended their attitude to include a greater respect for the plane's virtues, and the name was shortened to Hog. Still perhaps unflattering, but far more affectionate. Many lessons of the Second World War had been considered redundant after the development of the atom bomb. Some strategists proclaimed that conventional warfare would never be fought on a large scale again. Too soon, the Russians also had the bomb, and the usefulness of atomic weapons came into question. There seemed little point in nuclear devastation when there was a danger of retaliation. The germ of mutually assured destruction was sown, and a new concept, limited war, was post-dated to cover the Korean conflict. In that limited war, the Thunderjets were one of the most effective weapons available. By the end of the Korean War, in 1953, a series of confrontations and negotiations had completely rearranged world politics. This process was formally culminated in Paris on October the 23rd, 1954, with the ending of the occupation of West Germany. From that date onwards, English, American, and French troops remained in Germany as friends to help its defense. The Germans, many of whom were still deeply shocked and ashamed by the revelation of what their government had done in their name, found themselves welcomed back into the family of nations. On the 13th of November 1956, another step in this process occurred with the handing over to the German Luftwaffe of their first combat planes since the end of the Second World War. The planes were F-84F Thunderstreaks. Eventually, the Germans would deploy 5 full wings of Thunderstreaks, making them the largest user of the planes outside the USAF. Thousands of F-84s, both straight-winged and swept-wing models, were deployed by NATO countries. In addition to the Germans, they flew with the French, Belgian, Portuguese, Turkish, Dutch, Greek, Danish, Norwegian, and Italian air forces. They were the front line in Europe at a time when it came very close to open warfare and performed sterling service. The last of these operational, with the Turkish Air Force, were phased out of use only in 1982. The Republic planes, despite their limitations, were one of the most effective and important aircraft available. They were phased out when better planes were developed, but until then, they were the best that could be found. One other version of the F-84 was to be made in significant numbers. This was the RF-84F, the Thunder Flash. Korea pointed up the need for a high-speed photographic reconnaissance aircraft, capable of doing the job and avoiding interception by the MiGs. The new photo plane would need a longer range and much higher speed than the aircraft then being used for the job. The second swept-wing prototype had already been constructed with a closed, pointed nose and wing intakes, though these developments were never incorporated into the fighter version. It was on the basis of this airframe that the Republic designers started work on the reconnaissance aircraft. In the end, it was the most successful production aircraft of the whole F-84 family. The prototype RF-84 took its first flight in February 1952, and by then the design had been changed considerably. The wing intakes and wing surface had both been increased, and the neat pointed nose had been replaced with a blunter affair which could house 6 cameras. After successful testing, the plane was put into production, and 718 of the model were constructed. Production was delayed until 1955 by difficulties with the engine for the new version, but eventually they started to flow into operational use. The USAF deployed 11 squadrons of Thunder Flashers, and they served with the Air Force and National Guard for 17 years. The US military assistance programs also supplied 327 of them to a number of Allied countries. They had been intended as a stopgap and were replaced in the US front line by McDonnell RF-101 Voodoos after only 3 years' use. However, their long subsequent career with the National Guard underlines how effectively the Republic team had addressed the photo reconnaissance task and how valuable this version was. As with all the F-84 family, maintenance and ground operation access was simplified. This was not only an important virtue of the type, but was an influence on later designs. Even the first Thunderjets had over 180 access panels. The entire tail after the wing could be removed to simplify servicing the engine. It was part of the detailed work of the design team that was largely irrelevant to the aircraft in flight, but very important in the operational viability of the plane. Among the milestones posted by the Thunderjets was their time in use with the USAF's Thunderbirds, the display team. It's uncertain whether the team took its name from Republic's plane, but what can be said with certainty is that the first aircraft employed by the team on its formation in 1953 were F-84s. These were the straight-wing F-84Gs, and the team flew with them for 2 years. For the 1955 season, the Thunderbirds took delivery of new aircraft. Once again, these were F-84s, a swept-wing F model. With their wings only 5 feet apart, the planes look as though they're touching. This type of formation flying, with a plane as unmaneuverable as the early jets, is extremely dangerous. The Thunderbirds flew 91 shows with the F-84F, ending with the Armed Forces Day show at Bolling Field on the 19th of May 1956. They then transferred to the North American F-100 Super Sabre and gained supersonic capability. However, the shows in their new planes would be flown in much the same speed bracket as with the F-84s. One of the factors that made the F-84 such an important aircraft in the post-war years was the amount of experimentation, testing and evaluation that went on with the type and with variations developed from it. The FICON story is one of these important footnotes in aviation history written around the F-84. The name FICON is derived from the term fighter conveyor, and the project was a response to the need for aerial surveillance. Large reconnaissance aircraft had become too vulnerable for operations over hostile territory, yet much of the territory which had to be overflown was well outside the range of a fighter, let alone the endurance of its pilot. The scheme was simple in conception, but was far more complex to carry out. In effect, a B-36 bomber acting as a mother ship would carry the photo reconnaissance fighter for all but the dangerous part of the mission, launching and retrieving it in flight. A series of attachments, both for the bomber and the fighter, were developed before a reliable system was reached. It was difficult and highly dangerous. The project testing began with a modified F-84E in 1952. During these tests, changes were made to the gear in a series of steps as problems arose, first with the stability of the cradle on the mother ship, and then with the trustworthiness of the fighter's hydraulic grapple. The intended effect was achieved with all the apparatus trialed. Increasing effectiveness followed as refinements were made. The fighter was near to stalling at the low end of its speed range as it wallowed beneath the large plane, buffeted by the slipstream. The process called for a high degree of ability on the part of both pilots. The aircraft intended for operational deployment in the job was the RF-84F, modified and redesignated the RF-84K. Tests with this version commenced in 1953, and on the 30th of March, the prototype made its first successful docking. By this time, the mechanisms had been resolved. Modifications to the F-84 included drastic remodeling of the horizontal tail to allow the plane to be retracted into the B-36 bomb bay, in addition to the 3 hydraulic latches. Testing of FICON continued until 1955, and production aircraft were then deployed. The 91st Strategic Reconnaissance Squadron, based at Larsen Air Force Base, received 25 of the specialized RF-84Ks and were teamed with a squadron of modified B-36s. Experiments and in-squadron training continued until 1956, when they were abandoned. By coincidence, this was about the same time the U-2 became available for use. One of the nightmares that beset planners after the Russians had developed their own atomic weapons and delivery systems was that airfields could now be totally destroyed, along with all their aircraft, in one hit. This and several other factors, including the apparently insatiable appetite of jets for long, straight concrete runways, combined to lead to one of aviation's stranger manifestations. This was the system known as Zero-Length Launch, or ZEL. This scheme aimed to shoot manned and nuclear-armed aircraft off the back of trucks or out of concrete bunkers. It was intended that hundreds of aircraft could be dispersed throughout forests and in other hiding places around the Soviet bloc's borders. These planes could be ready, fully armed, to respond immediately to any Soviet attack. Another scheme would have placed interceptors on similar apparatus in hardened concrete bunkers to respond to any incursion by Soviet strategic bombers. In tests conducted by the Martin Company with equipment that had been developed for the Matador missile program, the system was trialled with unmanned F-84G aircraft and apparently worked well. The first launch took place on December the 15th, 1953, and the F-84 was rapidly accelerated from the truck and then allowed to find its own way back to Earth. another unmanned trial followed. The system relied on the use of very powerful solid-fuel rocket boosters attached directly to the aircraft. Once the fuel in the rocket was expended, the booster had to be immediately discarded, as it went from being a powerful source of thrust to a dangerously heavy drag on the aircraft. The tests demonstrated that by the time the rocket fuel had burnt out, the aircraft had been accelerated to 175 miles per hour. This was well above stall speed, and the plane should then be able to rely on the power of its normal jet engine to continue its flight. The two unmanned trials proceeded with so little deviation from the expected results that the project moved on to the next phase. The acid test for the system came with the third trial, when the plane was piloted. This took place on the 5th of January 1954. The recorded acceleration loads were 3.5 G, only slightly greater than a standard Navy catapult launch. The pilot had no difficulty taking control, and the test was considered a success. The project continued to 1959 with a series of later tests using North American Super Sabres. Orders were actually placed for 148 suitably modified F-100s. Interestingly, the Russians were involved in a series of similar experiments using MiG-19s at around the same time. The idea was finally abandoned with the development of more reliable and accurate missile systems. Experimentation with the F-84 continued to throw up a fascinating variety of variants. One of the more outlandish was the F-84H model, designed to be a supersonic, propeller-driven aircraft. This was truly a very different plane, and originally was designated the F-106. It had very little in common with the rest of the series, but was redesignated as the F-84H before its first flight. Two prototypes were ordered, with the aim of developing them for Navy carrier deployment. The aircraft employed a turboprop, and a series of propellers were studied for the design. Its first flight took place on the 22nd of July 1955 and passed with no real hitches. However, the plane failed to live up to expectations and did not actually pass Mach 1. It managed to reach 670 miles per hour, which made it the world's fastest propeller-driven aircraft, but was useless for the Navy's purposes. A major limitation on propeller-driven aircraft had already been recognized. At speeds nearing Mach 1 and then passing through it, different parts of the propeller would be simultaneously traveling at speeds above and below the speed of sound. The stresses involved are massive, and the whole area of propeller design and construction needed revolutionary changes to cope with the various loads that would be encountered. As a test vehicle for the assessment of this technology, the plane was very valuable. Experiments with the F-84H proved the ruggedness of the three-bladed propeller and the soundness of the engineering of the power plant and aircraft. However, with the introduction of steam catapults, angled decks and in-air refueling, the Navy was able to abandon the project and employ true jet aircraft. This left the US Air Force to pursue the project as a matter of basic research and development for its own purposes. In addition to being the world's fastest propeller-driven plane, the F-84H holds another claim to fame. It's generally acknowledged as the noisiest aircraft ever built. The engine was a large Allison unit, developing nearly 6,000 horsepower, but this was only a minor factor in the din of the aircraft. What really made the racket was the propeller. At high revolutions, even in ground maneuvers, the propeller tips went supersonic. This meant that the plane emitted around 900 sonic booms per minute, and these combined to make an astonishing row. The noise was such that ground crew involved in the test series suffered malaise and nausea if they were anywhere near the aircraft during taxiing run-up or takeoff. This was true even if they wore earplugs. The effect on a carrier's deck of a squadron of such aircraft preparing for takeoff would undoubtedly have been bad for operational efficiency. The plane and supersonic propellers were quite sensibly abandoned. Perhaps the most outstanding derivative of the F-84 was the XF-91 Thunderceptor. This 1946 design stands as one of the most amazing experimental aircraft of its era. It was fitted with 4 rocket chambers in addition to a powerful jet engine. It was the first US combat plane to break the speed of sound in level flight. The aircraft wings pivoted to give a variable angle of attack. Together with full-length slats, this gave the plane a very low stall speed for the time and allowed in-flight maneuvers that remained unique. The wings themselves were another radical feature, tapering in from the tip to the fuselage. This reversed the effect of wingtip stall, turning dangerous pitch up into easily controllable pitch down. If it had been fitted with the intended power plants, it was expected to fly to Mach 2, but even with the limited power of the available engines, it was capable of Mach 1.2. Though clearly the most advanced design of its era, it was not proceeded with on the basis of cost. Republic was a very ambitious company, committed to advanced design, and another of their projects, again not put into production, was the Mark III XF-103, a delta wing which used both a turbojet and ramjets. This plane had no canopy as such, the pilot being totally enclosed. An F-84 was employed to test periscope systems for the XF-103 pilot, and this strange mutant Thunderjet established that the system could be made to work. In Air National Guard hands, the F-84 persisted for a long and uneventful career, still plagued by its groundhog takeoff, but trusted and respected by its pilots. While they spent most of their time with the USAF as a second division aircraft, for many nations they were front line. For many of these air forces, the F-84 was persisted with, not only because of budgetary constraints for the purchase of replacements, but because they worked well enough to deserve their attention. The F-84 slipped into history virtually unlamented. Their reputation was tarnished by development difficulties and the fact that they were always underpowered. However, to dismiss them is to overlook their achievements, particularly in Korea. They deserve a reassessment and recognition of just how significant an aircraft they were. Like the rest of the first generation of jet fighters, the F-84 was effectively a transition between the piston engine planes and the more effective aircraft known as the Century series, the second generation of jets. The Century fighters were more successful simply because they could draw on a wealth of knowledge gained in the careers of the initial series of post-war aircraft. Within the first generation, the Republic planes were outclassed by only the F-86, which itself was a later design and drew on the knowledge gained in the F-84's career.
Okay, let's start moving in slowly. 330. Hard turn to the right.
The F-84 can be seen in hindsight to have had many virtues in an era when aircraft design had run into areas of great uncertainty. The problems of developing jet engines to deliver power and reliability were forced to one side by military considerations. The availability of even very limited jets had made propellers totally redundant. Propeller-driven aircraft were well understood and very reliable, but need compelled the transition to a far less advanced and trustworthy technology. As Korea demonstrated, the F-84, for all its faults, was the most dependable and rugged of its contemporaries. The F-86 is remembered as the plane that bested the MiG-15, but the F-84 was the plane that operated from the worst strips under abominable conditions and helped to stem the tide of Chinese intervention with a hail of accurately employed tactical firepower. In addition, during its career, it was host to a large number of experiments and developments that changed the face of aviation and have had effects that can still be seen in aviation science today. In a very distinguished family, the F-84 sits between two of the most successful tactical fighters of all time, the P-47 Thunderbolt and the F-105 Thunder Chief. And given their era, they survive a comparison very well.